Okay, in this video, we're going to be solving inequalities. And before we solve them, let's remind you how to write your answers. So let's go back over set notation and interval notation. So let's look at number one here. If this is our solution, if we're talking about all numbers from 3 on, okay, that would be in set notation, that'd be all values bigger than, this is 3 right here, greater than, or since it's shaded in, greater than or equal to 3. Now, sometimes we'll just put x is greater than or equal to 3, but when we're talking about set notation, we're going to be talking about a set. The set of all values, we'll call it x, such that, again, that's what that line means. The set of all x's such that x is all values greater than or equal to 3. Now, in interval notation, we know that's all numbers from 3 to infinity. So let's put all values from 3 to infinity, including 3. And we never include our infinities. The second one, the set of all x's, such that, and that's just a line, that's just a vertical line. X is all values, okay, we're smaller than -6, but we're not equal to. So it's just x is less than -6. And that would be all values from negative infinity. We always list the smaller value first, up to -6. And since -6 is not included, we do parentheses, and we never include our infinities. Okay, the next one, notice that everything is listed. So that would be the set of all x's such that x, we can put this, x is an element of the real numbers. That's one way of writing it, or we could just say, instead, we could just say x is all real numbers. X is everything, and that'd be every value from negative infinity up to positive infinity. Either one of those would be fine. Okay, writing compound inequalities. The first one is an or statement because x could be anything from here to here or anything from here to here. So that'd be the set builder would be the set of all x's such that x is less than, let's see, this is 1 right here. X is less than 1, and notice that it's not or equal to, or x is greater than 5. So we're less than 1 or we're greater than 5. Now in interval notation, that'd be all values from negative infinity up to 1, not including 1. Or is written as a U. It's called the union of all values from 5 to positive infinity. Okay, number 6 is an and statement because x, since it's between, that means x is bigger than this and it's smaller than this. So that would be, I skipped 5. Let's do 5. 5 is also an or statement. The set of all x's such that x is less than, not or equal to, -7. Or x is greater than or equal to +2. And it's or because we see it could be any of these or any of these. And that'd be all values from negative infinity up to -7, not including -7. So parentheses, or all values, not parentheses, but brackets because we are including 2, all values from 2 to infinity. And again, now 6 is an and statement because it's a middle region. Here we have the set of all x's such that, and we can write this as a sandwich. I can write it both ways. We can write it as a sandwich or we can write it as an and statement. So here x has to be bigger than -4 and x has to be smaller than 0. So that's one way of writing it. Bigger than -4 and smaller than 0. It must satisfy both of those because even though this value over here is bigger than -4, it's not smaller than 0, so it's not in between here and here. Again, we can combine that and write it as a sandwich as well. We could say -4 is smaller than x, and x is also smaller than 0. So that's another way we could write it. Or we could say in interval notation, which is hands down the best notation, x is from -4 up to 0, all values. That's it. All values from -4 to 0. The last one, in set builder, the set of all x's such that x has to be greater than or equal to this value, which is -1, and x has to be smaller than 8. So that means all the values between -1 and +8, not including 8, but including -1. Or again, let's remind you how to write that as a sandwich. That'd be all values, let's see, -1 is smaller than x, or equal to, and x is smaller than 8. That means x is between -1 and 8. Now in interval notation, that'd be all values from -1 up to 8. Including -1, so bracket, not including 8. Now that we've reminded you how to show your answers, now we're going to solve some of these inequalities. We're going to graph them and write our solutions in both, it says both set and interval notation. So first off, distribute to get rid of parentheses. That'd be -12x and a +6. Bring down -4x is less than -90. Combine all like terms. That'd be -16x plus 6 is less than -90. Move +6 by subtracting. That's -16x is less than -96. Now here is the only difference between equations and inequalities. Just a reminder. If you move a negative by multiplying or dividing, I've got to divide by -16 here. When you move a negative by multiplying or dividing, this inequality symbol has to flip over. So you get x is greater than 6. So that means that your solution will be the set of all x's such that x is greater than 6. So we're going to do an open circle at 6, and that's going to shade everything to the right, all values greater than 6. So that would be all values from 6 to infinity. So there's set builder notation, here is interval notation, and there is your graph. So over on the left side, let's finish this statement. Watch out. When you multiply or divide by a negative, flip your inequality. Let's not forget to do that. Flip your inequality. Okay, number 9. Zoom in a little bit. Distributive property, multiply everything by -5. That'd be 10x plus 35 is less than or equal to 7x plus 23. Move all your x's to the same side. Subtract 7x gives you 3x. Bring down your symbol. Subtract 35 gives you a -12. Here you're dividing by 3. Since 3 is not a negative, do not flip your symbol. X is less than or equal to -4. So set builder notation would be, your answer is all x's as long as x is less than -4 or equal to. So let's solid circle, shade everything smaller than or less than -4. There's your answer. So that would be all values from -infinity up to -4, including -4. So set builder, interval notation, and your graph. Okay, number 10. Solve the inequality. If you would like to, we've got some like terms here we could go ahead and put together. -8x minus 2 is greater than or equal to, distribute, that'd be -8x minus 2. And we already see what's going to happen. The left side and right side are the same. So when we move our 8x over here, we move our +2 over here, they cancel. And it leaves me with 0 is greater than or equal to 0. Okay, anytime you're solving inequalities and you come out again with a true statement, it's the exact same thing as equations. Even though 0 is not greater than 0, since you have or equal to, 0 does equal 0, so this is true. So your answer is going to be all real numbers. So all reals. That would be all values from, if you want to do it as a set builder, set of all x's such that x is an element of the real. So therefore, if x is a real number, then it's in this set. If you write it in interval notation, that'd be all values from negative to positive infinity. The graph would be the entire number line. You would shade everything in. Number 11, distributive property is going to be 40 minus 16x is greater than -10x plus 40 minus 6x. And it looks like the same thing is going to kind of happen here. 40 minus 16x is greater than 40. Combine your x's and you get minus 16x. And it's the same on both sides. However, when you move your 40 over and you move your 16x over, you end up with 0 is greater than 0, which is a false statement. So anytime you have a false statement, then there is no solution to this inequality. Okay, number 12. We actually have a different set of directions here. We're solving absolute value inequalities. Now, here's how we solve absolute value inequalities. To solve it, step number one, we isolate the inequality. We're actually going to isolate the absolute value, is what I wish they'd have put there. We're isolating our absolute value bars. We're going to create two cases, and we're going to solve both cases. Now, this is where we're going to use the KISS method. And we'll talk about what KISS means in just a second. So, step number one, let me remind you of something else. For all greater than or equal to's, greater will be or statements. For all less than or equal to's, these will be and statements. So we're going to isolate, we're going to get our absolute value by itself. If it's greater than, we're going to write an or statement. If it's less than, we're going to write an and statement. Then we're going to do all this other stuff. Okay, so here we go. Step number one, this is isolated. Step number two, we're going to create two cases. 5 minus 2a is greater than 15. Since it's greater than, this is an or statement, so we're going to put or. Our second case, this is where KISS comes in. KISS stands for keep it, switch, switch. So for our first case, we're going to keep it the same. All I did was I dropped the bars. For our second case, we're going to do 5 minus 10a. SS stands for switch, switch. We're going to switch our inequality over, and we're going to switch 15 to negative 15. Keep it the same, switch, switch. And again, the or came from it being a greater than. Now we simply solve, and we're done. I'm going to move my 5 over. It gives me negative 10a is greater than 10. Or, yeah, that's right. Divide by negative 10 gives me a is less than, because I'm dividing by a negative 10, negative 1. Or, move my 5 over, gives me negative 10a is less than negative 20. When I divide by negative 10, make sure you flip your symbol over and you get a is greater than 2. So my solution set is all values that are greater than 2. So an open circle, shade to the right. That's part of my answers. Or any value that is smaller than negative 1. So the values that would satisfy this inequality is pretty much anything except for these certain values, these in the middle. So any value from negative infinity up to negative 1. So let's write this in interval notation. Any value from negative infinity up to a negative 1, not including negative 1, or any value from 2 to infinity. That's going to be your solution as in interval notation. Or set builder notation would be the set of all a values here such that a is less than negative 1. Pretty much I'm just copying this up here. Or a is greater than 2. So there's all your different answers. Number 13. First off, let's see, we're going to isolate it. It's already isolated. We're going to create two cases. Negative 2 minus 8x is greater than or equal to 30. Keep it. And then switch, switch will be negative 2 minus 8x. Switch the symbol and switch the positive to a negative. Since it's greater than, it's going to be an or statement. Solve each, gives you negative 8x is greater than or equal to 32. Divide by 8, negative 8. Make sure you flip your symbol over. You get x is less than or equal to negative 4. Or add 2 gives you negative 8x is less than or equal to negative 28. Dividing by negative, let's see, that's going to be x's. Make sure you flip your symbol since you're dividing by negative 8. A negative divided by a negative is a positive. So we do have to reduce that though. That'd be x is greater than or equal to, divided by 4 would be 7/2, which is 3.5. Okay, I didn't read my directions, but we actually don't have to do set builder notation on this, and we've seen enough of that anyway. So my solution, here would be one way of writing our answer, and you could put that very easily in set builder notation. But now let's look at the graph of that. X could be anything less than or equal to negative 4. So any of these values, or x could be any value. 7/2 is 3.5, so that's going to be right in there. So any value greater than or equal to 3.5. So that is all values from negative infinity up to negative 4, including negative 4, or any value from including 3.5 to positive infinity. There's your interval notation. Number 14. Again, first step, we always have to isolate our absolute values. So absolute value of x minus 3, move your negative 4 over. You get less than or equal to positive 4. And let's keep it switch to create our two scenarios. X minus 3 is less than or equal to 4. Kept it all the same. And then switch would be x minus 3. Switch your symbol, switch your sign. Since this is a less than, this would be an and statement. Now let me show you a trick how I remember greater than and less than, like which should be which. Anytime you have a greater than and anytime you have a less than, I try to remember greater, less than. Greater, anytime it's a greater or greater than or equal to, it'd be an or statement. So I think to myself, greater. Anytime it's a less than, I think of the words less than. I kind of blend those together. So less than or equal to would be an and statement. So let's solve each. You get x is less than or equal to 7, and add your 3, x is greater than or equal to negative 1. Now, if you did this correctly, it should be like a sandwich. So let's find 7 and negative 1. Put a dot, and there those two are. So x is going to be values. They have to be bigger than negative 1, and it also has to be smaller than 7, which means it has to be between negative 1 and 7 because both must be true. So that would be all values from negative 1, including negative 1, up to 7. So there's your solutions. Number 15, divide by 8 to isolate your absolute value bars first. It gives you greater than 15. This is a greater. This is an or statement, so you can go ahead and put your or if you would like. You do keep it, switch. 3 minus 3x is greater than 15. That's keep it. Now let's do 3 minus 3x, switch and switch your symbol and your sign. Move the 3 over, gives you negative 3x is greater than 12. Divide by negative 3. Make sure you flip your symbol, gives you x is less than negative 4. Or move your 3, gives you negative 3x is less than negative 18. Divide by negative 3 gives you x is greater than negative divided by negative is a positive. So x can be any value less than negative 4. And if you do these correctly, or statements should always on these face away from each other. And statements on these should always point towards each other. So x could be any value from negative infinity up to negative 4, or any value from 6 to infinity. And you can always check this by, you can take either one of those. You could take the number negative 5, you could take the number 7, 8, 9, any of those numbers, plug it into this, and any of those should make this a true statement. Number 16. Let's get rid of the 4 by multiplying. So the absolute value of 12 minus 4x is less than or equal to 8. This is a less than, so it would be an and statement. Keep it, switch would be 12 minus 4x. Keep it. And because it's less than, 12 minus 4x, switch. And that's greater than or equal to. Solve each. Negative 4x is less than or equal to, when you subtract 12, gives you negative 4. When you divide by negative 4, flip your symbol, gives you 1. And negative 4x, when you subtract 12, gives you negative 20. When you divide by negative 4, make sure you flip your symbol and you get 5. So since this is an and statement, let's see if it points the direction it should. X, let's plot 1 and 5. X is any value bigger than 1, and it also has to be less than 5, so that means it's between 1 and 5. So my answer is all values from 1 to 5. So if I plug in the number 3, 2, 4, any of those into this inequality, it should be a true statement. Number 17. We've got to move our 5 over. And if you're getting pretty good at these, if you'd like to move them both over in the same step, that'll be fine. So add 5, then we got to divide by 9. 2 plus 6x is less than 8. This is an and statement because it's a less than. So we're going to do keep it, switch. 2 plus 6x is less than 8. And because of less than, 2 plus 6x, switch. Move the 2 by subtracting gives you 6. Divide by 6 gives you 1. And Move the 2 by subtracting, gives you 6x is greater than negative 10. Divide by 6. You do not flip it because 6 is not negative. And it gives you negative 10 over 6, which we need to reduce. So that'd be x is greater than negative 5/3. So let's find 1 on our number line, which is right here. And negative 5/3 on our number line, that's negative 1 2/3. So negative 1 2/3 is somewhere right in here. Okay, open circles. And x is smaller than 1 but bigger than negative 5/3, so that means it's between because it's both. It must be both. So therefore, our solution is all things from negative 5/3 up to 1. Non-inclusive because it does not contain or equal to's.